to our channel, and today we will be solving this problem, trapping rainwater, which is a Leetcode hard problem, and it is asked in many top companies in interview rounds. And we will first try to understand the problem, then come up with the order of n solution, and later on we are going to optimize the memory usage also, where instead the space complexity is order of n, we will optimize it further to order of 1 and try to see how we can optimize this. So without further ado, let's straight away jump into the problem statement, that is trapping rainwater. So if you see this grid, right, you are given a 2D grid and you have to find how much water is getting stored in this grid. For example, here you see the water stored is 1, here water stored is 1, here water stored is 2, okay, and here again 1, and here again 1. So the answer here is 1 plus 1 2, 2 2 4 5 and 6. So hence your output is 6, right? So so if you see this grid, you are given the height of the array. So for example, here height is 0, here 1, here again back to 0, here 2, right? So this is how your height array is defined. And yeah, so if you see this problem, it has, what is your general intuition? So general intuition is that if you see this problem, then you can see there's something going on between the heights. For example, if you are at this index, then the water trapped would be how much water you can store. It is looking something like minimum of these two heights, right? I'm just thinking about the intuition. And what is the water trapped? The current height. If you take the current height is 0 minus the minimum of these two heights. Okay, so can I say that like if at every index I know what is the maximum height on the left side and what is the maximum height on the right side, I'll take the minimum of it, right, and subtract it with the current index height, right? So it will give me what? The water that is trapped within that index, right? So this is very obvious, right? So how can I solve this? Is maintaining two array, like the prefix array you can say, which is one array will store the maximum values that are stored from the left, and one array will store the maximum values stored into the right. Okay, so I'll explain you something like a pseudo code here, where I will have a left array, okay, and I will have a right array, and left array will contain the maximum from the left, and right will contain the maximum. Then at any given point I will say water that is stored would be equal to minimum of left of the current index comma right of the index minus the height, which is the current of height. And if I take this, at last I will return the water that is trapped. Okay, so this is what I'm going to do, and I will be coding this is in Java. So let's move ahead with the solution and try to see how it works. So let's say if I get I'll start the coding part. So you will have height dot length, and you can store left is equals to new int of n, int of n, and then you can traverse. Basically you can say left of 0 is equals to height of 0, and right of 0 height of n minus 1 is equals to height of n minus 1, right? I is equals to 1, I less than n, I plus plus, and left of I is equals to math dot max left of I comma height of I. So it will keep on storing the maximum height that is present till that index, right? The next thing you can do is I is equals to n minus 2, okay, and let's say I take a variable, let's say int water that is trapped is equals to 0, and then I can start with index 0, I less than n plus plus water plus equals to, what I need to do, I have to take the minimum of these two index, right, left of I comma right of I, that is the minimum, and now I take the current height, that is I, that is the stored into our array. And yeah, I mean that should be our answer. We can return water, and let's try to run this. It works fine, and I'll submit the solution. Okay, so this works perfectly fine, and I will now explain you like what has happened. So here what would happen is when I stored left, so what would be my array? So for example, I run it through this test case. So this is the initial array. Okay, so initially your height array is this, and then when you do this, then initially your array, the left array would be 0 0 0, everything would be 0. So now you have 0, then the maximum is this, then again if you compare with I minus 1, this would be the maximum, then 2 becomes maximum. Okay, then again 2 2 2, then 3 3 3 3 3, right? What is the size? 1 2 3 4 5 6 7 8 9 10 11 12. 12 is the size. 1 2 3 4 5 6 8 9 10 11 12, right? So this is correct. Now when you store it from the right, so your right array would become what? After this iteration, you start from the back side of the array, right? So you have initially 1, then you would have 2, then you have again 2, right? And what else? Now again you will have 2, and then you would have 3, and then other index would be 3. So how many times? 1 2 3 4 5 6 7 times. 7 times more 3 you have to put. So let me write it. 1 2 3 4 5 6 7, right? That's it. 7 and 5 is 12. Okay, so now you have this array, you have this array. Now let me just put them here. Now what happens? This is your one array, this is your other array, okay, and this is your third array which was above. So this was your initial array. Okay, so now what we will do is we will compare them. Okay, so this is your array. Perfect. Now what happens here when you are calculating, so you will store how much what is stored, right? So now what do you do? This is your initial array, then you take a minimum of both of them. What is the minimum of this? Let me say this is your right, this is your left array, this is your right array, and this is your height array. Correct. Then what happens is you take the minimum of both of them and subtract. What is the minimum? 0, and 0 minus 0 is how much? 0. So what are stored at index 0 is 0. Now you take the minimum of both of them, 3 and 1, that is 1. 1 minus 1 is 0. So index 1, how much what is stored? 0. Now you go to index 2, take the minimum 1. 1 minus height array is 1, right? How much what is stored? 1. Then 3, what is the minimum of these two? 2. 2 minus 2 is 0. Know what is stored at index 3. Okay, similarly minimum of these two is 2. 2 minus 1 is 1, so index stored is 1. What is stored is 1. Minimum is 2, what is stored is 2. Now what is the minimum? 2. 2 minus 1, 1. Now 3 minus 3 is 0. Similarly, if you see minimum is 2, 2 minus 2 0, then here again you will get 2 is the minimum and 2 minus 1 is 1. Here 2 is the minimum, 2 minus 2 is 0, and 1 is the minimum, 1 minus 1 is 0. Okay, so how much what is stored? 1 plus 1, 2, 2, 4, 5, 6. So what is your answer? 6 is your answer here. Okay, so hence we will return 6. Okay, perfect. So what concept is being used here is the prefix sum, not the prefix sum, but similar concept where you are storing the maximum in an array. So you are basically pre-computing. Okay, so that relates to a dynamic programming concept where you are pre-computing and using the results in your future answers. Okay, so this is here what is being used. So the paradigm is dynamic programming here, and the time complexity of the solution is order of n. So let me just write it down. Time is order of n, and what is the space complexity, folks? It would be order of n again. Okay, makes sense. So now this is what the expected solution in your interview would be. Now let's say your interviewer wants you to optimize it. Okay, so how would you optimize, right? So what you are doing, you are calculating everything, right? But it is possible that you are storing, right, too much things, that is order of n. Now I want to make this as order of 1. Okay, so how would you do that? So here you have to think like, can I do it like optimally, where I'm calculating the minimum heights on demand, right, lazily, and I don't want it to happen for each index, just that when there is a heights are changing, then if I do it, will that help me or not? Okay, so that can be achieved through 2 pointers. Imagine you are at this left index, you are at right index here. Now you keep a value left maximum, and you will keep a value right maximum. Left maximum, as you are iterating from left side, you will keep on updating the left maximum. As you are moving backwards, you will keep on updating the right maximum. But when the heights are the left height and the right height is greater, right? So when the left index height is lesser than the right index height, that means your minimum is the left height, so you need to update the left max. And when the right height is greater than when it is lesser than the left height, that means you have to update the right max, and you have to calculate the water. And what you can do a left plus plus and right minus minus to store. I think you might not understand this, but if you understand the previous solution which I did, then you can understand this one easily. So let me do one thing. These things remain same. What I can do now is, let's say I have a left maximum and it is stored as 0, into right maximum stored as 0. Now I have a left pointer which points to 0, and let's say right pointer which points to n minus 1. Water at last I would be returning, so let me maintain this variable as 0. and I can do a 2-pointer algorithm where I have left less than right. Okay, so what I can do here, if let's say height of left is lesser than the height of right, that means what? That means that your minimum is the left index. You already know that, right? And but there is a catch, whether this left is the maximum or not. If not, you update it. Simple. So if height of left is greater than left max, then you update the left max height of left, and if it is not, that means you already have the maximum value. So in that case, water plus equals to left max minus height of I, not I, left, right? And you do a left plus plus. Agreed, right? And if this is not the case, then that means your height of right is less. So same thing you have to do for the right case, just that you have to do height of right is greater than right max. So right max equals to height of right, water plus is equals to right max minus height of right, and you have to do a right minus minus. Okay, so now the same thing is happening here, but we are not pre-computing anything. We are doing it on demand, and if you see, we are not using array anywhere. So it is just variable. So the time complexity and the space complexity varies here, because here time complexity would still be order of n, because you will be traversing all the elements from both the sides, and space complexity would be order of 1 here. Okay, so let me run this solution first and see if it is working. So all the test cases passes, and I will submit it. So it works perfectly fine, and now the space complexity becomes order of 1. So we are doing it on demand. So this is the 2-point algorithm which solves this problem, and this is really nice. And if you like the video, support us by liking and subscribing to our channel, and hit the bell icon for future videos and update. I'll be solving a lot more problems, and other exciting things are coming up. So yeah, see you soon.